We will talk about the project, the partners involved, and the tests that we've been doing with it, and what came out of that. At the end of the presentation, there's some time for people to try it out. Maybe not that much time because we're on a tight schedule, but we'll see how far we get there. First, the partners. Valence was a collaborative project. We didn't do this alone. And the idea is that a few partners were involved, some of them in the hardware, others in the software, and even others in just graphic design elements. And I would like to go over the partners and their contribution to the project. eMERGE, or EMRG, which is the Experimental Media Research Group, that's where we come from, me and Tom. So I'm Lieve Mensgaard, this is Tom de Smet. And we are located in Antwerp, Belgium. And we're affiliated with the University of Antwerp and with the art school, St. Lucas Art School of Art and Design. We develop, or we do research on graphic modeling and modular interfaces, and also on text mining, which is just Tom working on that. And the idea is that we produce, or we show our research by writing open source software for people who can use it then. Maybe the best known probably are Notebox and Pattern. Valence also was done in Notebox, which it has a few versions. The version that we used was Notebox for OpenGL, which is for this kind of experiment the best tool in our arsenal. Of course, we could use other tools like processing or stuff like that. EMAC, sorry, we had EMAC. No, sorry, we didn't have EMAC. EMAC is the Inter-University Microelectronics Center, and it's a very big research group located in Leuven, also in Belgium. It has a few site research labs also here in the US and in Taiwan. And the idea is that they do research on nanoelectronics and nanotechnology. And they build, in fact, building blocks they do research on building blocks for the industry. And the industry being research in better healthcare, smart electronics, sustainable energy, and safer transport. The research they've been doing on this project was in this headset, which is a wireless EEG headset. And they concentrated, or they focused on long-time battery use, because they wanted patients to be able to wear it a whole day, and the wireless connection, but we'll get to that later. Then the host center is an independent open innovation art research and development center, which is located in the Netherlands, Eindhoven. It was started up by EMAC and TNO, which is something similar than for EMAC, but then in the Netherlands. And the idea is that they do partnerships with the industry and with academia who has shared roadmaps and programs. And the idea is that they also build small components for the industry. And it's also in healthcare and medical advices. Whole center was set up in 2005, and the name comes from Gilles Holst, and who was the first director of the Philips Research Center. I don't know if Philips is that known here, but in Europe it is. Then Ludivine Luchat, who we work a lot of times with Ludivine. She produces, or she's a generative artist, which produces artwork for procedural design. The idea is that she creates recombinable vector graphics, which we use in our software. And she gets its inspiration from nature, or she's at least inspired by nature. And the inspiration for Valence came from microscopic life, and so it has this sort of feel to it. This is a few of the components he made for something else, which was a project by Tom and Ludivine, and it's a very big mural for the offices of EMAC. And it's called Nanophysical, and the idea was to have a graphical interpretation of the research that EMAC is doing in their team. Then the last one is Tim Augustin. He's an electronics sound engineer, or is an electronics and sound engineer. He works with Belgian rock bands, and he helped us out with attaching the whole system to automation or a domestic automation module. He also warned us not to go through customs with our first prototype, so he built this little case which is safe, and they let us through without any problem. Then wireless EEG, electroencephalography, or EEG, records the brain's spontaneous ionic action activity, and the idea is that in, for instance, a patient who has epilepsy, you can see abnormal activity, and that can be observed by EEG analysis. And everybody knows EEG probably from in hospitals or things. The idea is that the researchers from EMEC and Holst made this, developed this wireless low-power EEG headset, and the aim is to improve the patient's quality in life. They should be able to wear it all day long, and it could mean that they could be monitored from a distance because it works over a network protocol, and they could be monitored while doing their just normal daily activities without going to a doctor and so on. The prototype, which this one is not commercially available, it's really a prototype just to build for a few experiments, because again, they don't make finished products, they just build certain blocks which are inside this. But it could be, the whole principle could be replicated with a commercial device like Epoch Emotive, which is a EEG headset, which costs about $200, I think, something like that. But the reading it gets is pretty much the same. The only thing here is that they focused on low battery usage and the wireless connection. The EEG headset itself is designed like this. It has a wireless connection. It has also a microprocessor, and then it has a few 6 in this example, dry electrodes. You have two different electrodes on EEG. You have the wet electrodes, which is a whole hassle because you have to do conductive gel on your head, even shave your head, then conductive gel, and then place on the EEG headset. This is pretty much 10 times that easy because you can just put it on your head, and the only thing that we have to say about it is that it really hurts. It's a prototype designed for people to wear it all day, but they really can't find anybody to do this because it hurts so much. After like 5 minutes or 10 minutes, you feel the connections in your head, and it's kind of sticky. The brainwaves which we record, or the brainwaves we can be recorded by EEG set, is in the first place alpha waves, which is an indication of relaxation. You can induce that by closing your eyes, and we started from that for our game also. The idea for the player is that he tries to relax to achieve the goal of the game. Other brainwaves are beta, theta, and delta, which we don't read. It has the capacity to read this because it gets a raw signal. It should have to be filtered out, of course. We only do filtering of the alpha waves. A second one we also do, and that's where the name comes from, is Valence. And Valence is a hypothesis which states that there's a right hemisphere and a left hemisphere in your brain, and the right hemisphere should be responsible for negative emotions, and the left hemisphere should be responsible, or would be responsible, for positive emotions. We tried to test it out, or to see if our games could induce that, but that's really not the case. It's kind of very hard to know why they come up, or or why we have a Valence reading, and there's not really something to pinpoint. I'm thinking about something negative, so I have feelings now, or I have negative emotions now. It's very hard to do that. They're still doing research on that in Holst Center. This whole thing had to be done, or we had to make the project in a few weeks because we made it for the World Creativity Forum, which was held in Hasselt last year, and it has a few iterations. We started out with deciding what software we wanted to use, of course, and it's strange that it's just showing one, but that's okay. The game world itself is done in Notebox OpenGL, and which is an open source software application that runs or that can create graphic visuals by programming Python code. The game itself consists of graphical elements. It's something strange is going on. Yeah. Wait, first, sorry. I have to get my battery. Yeah. Okay. Yeah, sorry. Our game world consists of particles which are based on agent-based simulation. The best known agent-based simulation is described by Greg Reynolds, which is called Boids, and it's instead a simulation of a flock of birds which don't run into each other, and they avoid each other by steering into a similar direction. And the idea is that we have one main particle which attracts the other particles, and the idea was to connect that to the alpha level. So if you relax, or in the game, if you relax, then you can attract the several particles to the main particle in the center. And the radius will increase, or the main particle radius will increase, the more particles that are attached to it. A second variation, or a second thing we did, or second iteration, uses pixel effects with GLSL. GLSL is OpenGL shading language, and it allows you to create pixel effects also at runtime from Python code. It's a subset of C program language, and just to describe hardware accelerated pixel effects. The final version has, or this version that you can see here now, has a ripple effect based on code by Adrian Boying, but we also implemented other pixel effects which are part of Notebox OpenGL, which is called Blur and Bloom. Then, once we have that basic principle done, then we can start importing the elements, or the graphic elements that Ludivine makes. And you see that it's a very rough thing now for the moment. And then we go to a final, because I just have 5 minutes, I see. So this is then the final version of the game. You can see the main particle building up on the left side, and it has a few effects based on, or a few GLSL shading effects. And what you can see here now is two sets of particles. There are the regular particles, which are the ones with the yellow dot in the center, and then there's a few colorful particles, like the one with the orange dot and the one with the little wings. And the idea was that to connect these ones to the valence. So if you are happy, or if you feel happy, then the feelies come around, and we call them feelies. And the idea is that you get more color because you're more happy than the other thing. Now, we've seen feelies while testing it, but we couldn't say, as I explained before, we couldn't say why, and the people which were testing also couldn't really say why that they saw the feelies. Last implementation was the implementation of light, and you see here a few testings that were done at also some kind of fair in Belgium. And the idea was to attach it to an automation module so we could trigger lights or the intensity of the lights going up. Why did we do this? Well, in the first case, because they asked us to do this, and in the second case, the game itself is for the player really hard to understand because he doesn't see anything, you know? He has to close his eyes because he needs to stay relaxed, and the only thing he could hear was pop, pop, pop if the particles went to the main particle. But the idea is if you have an intensity of light going up, you can even see it with your eyes closed. And then you can see when, wow, it's going, it's working, and that's what these things are. Now, the test that we've been doing, we've tested about 100, 150 people. The people that did it the best were small children because they, I don't know why, because they, of course, they could relax better in opposite to the discourse in Belgium and in the rest of Europe that kids really are hypertension and have ADHD and ADD disorders, needs Relatin pills, but they really could relax very well. Other people which were able to do it in a convenient way said that it had to do with their courses in meditation or relaxation, but of course that's something that we can't really prove or find out. About 20% of the people were unable to do it. Of course, in the setting, it would be like a setting in here. People are looking at you, people are a bit agitated, and it's kind of hard to relax for a lot of people in a crowded room, but 80% of the people could manage it in, sometimes not that long, even just 2 seconds or 10 seconds, between a period between 2 and 10 seconds. I don't know if there's still time. No, 1 minute, then we'll have to wrap it up. We were thinking about testing it out, but that'll be for the next one. Okay, thank you.